Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. Today we are going to start with A levels statistics 2 chapter Poisson distribution. Now to understand Poisson distribution, let me bring a scenario in front of you. Suppose if I say there is a check post, let me use a different color. Suppose if I say there is a check post and I say through this check post on an average 5 cars pass every hour. 5 cars pass every hour. Okay. Now, if I ask you that through this check post, you are supposed to find out the probability of more than 3 cars passing through this check post in an randomly chosen half an hour. Randomly chosen half an hour or 30 minutes. So how we are going to find this particular probability? Let's take another scenario. Okay, suppose there is a manufacturing company, some steel manufacturing company which manufactures metal plates or something like that. Metal plates. Okay, the manufacturing company manufactures metal plates, and the company claims that for every 10 meters square of metal plate area which the company manufactures, there is only one defect on an average. On an average. For every 10 meters square of metal plate the company manufactures. So if I have to find out the probability of that there are not more than 2 defects, not more than 2 defects in a randomly chosen 50 meters square of metal plate. So how we are going to find this? Before finding out this particular probability, what we would do is we would try to understand the terms which we have introduced here. Okay, so let's see one by one. So here what we have introduced is we have introduced the number of occurrences of certain thing. We have introduced something called as an event here. First of all, if you see, we are talking about a check post, and through this check post we are talking about the cars passing. So the event is that the cars are passing through the check post. Similarly, here there is an event that there is a metal plate, and through this metal plate we are talking about the defect. That's an event. Okay, then what we are talking about the number of occurrences of that particular event. Like here we are talking about 5 cars passing through, or one defect. Okay, then we have introduced something called as mean, or the average rate of occurrence of that particular event. Okay, like here if you see that every hour we are saying 5 cars are passing. So the average rate of occurrence of that event, which event? Cars passing through the check post, here is 5 cars. Similarly, here we have introduced the average rate of occurrence through the interval of space. Here we were talking about the interval of time. Here we are talking about the interval of space. What space I have used? I have used the spaced area. And how much area I am talking about? 10 meters square. So on an average, we are claiming that for a 10 meter square area, there is one defect. Okay. Then what we are trying to find out? We are trying to find out the number of occurrences in a randomly chosen interval for the same scenario. Okay, like we are talking about more than 3 cars passing here. Like here we are talking about not more than 2 defects. These we are talking about the number of occurrences of the event, said event. Here the said event is cars passing through the check post. Here we are talking about the said event is the number of defects, okay, through 10 meter square of metal plate. Okay, now what we can do is we can basically represent this number of occurrences with a random variable. Suppose x is the random variable. Okay, it is a discrete random variable. Why I am saying discrete? Because we are talking about the number of occurrences. It's a discrete random variable. Okay, so if x is a discrete random variable, and this discrete random variable represents the number of occurrences, represents the number of occurrences, the number of occurrences of what? Of a certain event, of a certain event. Okay, how? In a given interval of time or space. In a given interval of time or space. So if we represent the number of occurrences by a discrete random variable, then this discrete random variable happens to follow Poisson distribution. X follows Poisson distribution if it follows certain criteria, if it follows certain conditions. Follows Poisson distribution if it follows certain conditions. Certain conditions are met, then only then we can say that it follows Poisson distribution. What are the conditions? The first condition is that the events occur independently of each other. Events occur independently of each other. Occur independently of each other. So for the check post scenario, the cars reaching at the check post, okay, they are coming at the check post independently of each other. Okay, for the second scenario, for the metal plate, for every 10 meters square, okay, we are talking about the defect. These defects which occur, the defects are independent of each other. The second condition is that events occur randomly. Events occur randomly, occur at random. Okay, then we talk about something called as the condition. The third condition, that average rate of occurrence is constant. Average or the mean rate of occurrence is constant. Average or mean rate, this is very, very important. Mean rate of occurrence is constant. And the last point is that events occur singly. Events occur singly. Okay, That means there is a zero probability of simultaneous occurrence of the events. Okay, they occur singly. So these are the four conditions. These are the four conditions. I'll just write it here, the four conditions. In the exam, they ask you these particular conditions. Okay, but you will have to give these particular conditions in the context with the question what they have asked. You just can't write that events occur independently, events occur at random, or average rate of occurrence is constant, and so on. You will have to write down all this, but in the context with the question. When we will take examples, we'll come to know that. Okay, let's go ahead. So if I say if X has a Poisson distribution, if X has a Poisson distribution, with a constant average rate of occurrence, constant average or mean rate of occurrence, mean rate lambda. If X has a Poisson distribution with a constant average mean rate lambda, then we write this as X follows Poisson distribution. We write P with small o at the suffix here, and in the brackets we write the parameter lambda. Okay, we are writing this same statement in the symbolic form. X follows Poisson distribution. Then if I have to find out probability of X equal to R, X taking a value equal to R, what is this probability? X taking a value equal to R, this is the probability of R occurrences, probability of R occurrences, probability of R occurrences. Of a certain event, in a given interval of time or space, of time or space. Okay, like how I introduced in the top right now. I said for this check post, we said this is this number of cars passing through that particular check post. We wrote it as, we can write it as a discrete random variable, let X be representing the discrete random variable, be representing the numbers of cars passing through the check post. Then X follows Poisson distribution. I can say here X follows Poisson distribution with the mean rate as 5. Similarly here I can say X is the random variable of number of defects in 10 meter square of metal plate. So X follows a Poisson distribution of 1 defect in 10 meter square of metal plate. Okay, so we are talking about the number of occurrences. Okay, so probability of R occurrences of a certain event in a given interval of space of or time is given by e raised to minus lambda into lambda raised to R upon R factorial. Okay, where R takes a value, it can take any value from 0, 1, 2, 3 and so on up till maybe infinity. Okay, it can take any value. Okay, this formula, how it has come, from where it has come, it is beyond the scope of A level statistics too. So we have to directly take this particular formula. We just need to remember that probability of any discrete random variable taking a value r is given by e raised to minus lambda into lambda raised to r upon r factorial, where lambda is the parameter. Now if you see here, we have something called as letter E. You might know that E is nothing but an irrational number having some value as 2.781 something. Okay, and here there is something called as r factorial. You might have studied about factorial in the earlier grades. If you don't know, let me just introduce this one. Okay, suppose if I say 5 factorial, so 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. We start with whatever the number they have given, whose factorial we need to find. Okay, and we need to go on multiplying with the lower following digits up till 1. Similarly, 1 factorial is equal to 1 only, and there is one thing, something called as 0 factorial, and 0 factorial is also 1. Why 0 factorial is also 1? That we will learn when we will be doing statistics 1. Okay. Okay. Now let's try to understand certain points about Poisson distribution. Okay. For Poisson distribution, we need to remember certain points. What all points we need to remember? The first point is that the Poisson distribution has only one parameter. It has got just only one parameter. And what is that parameter? Lambda. It's not necessary that you have to use lambda as the symbol. Many a times if the question contains 2 or 3 scenarios, so we can use lambda, mu, different symbols. Okay, so lambda, and this lambda is basically greater than 0. But does it mean that it has to be an integer? Not necessary. Not necessary an integer. Now when I say not necessary an integer, what does it mean? Like, say for example, if I take this metal plate ka scenario, I say for every 10 meter square there is 1.5 defect. So it means that for 20 meter square there will be 3 defects. For every 20 meter square there are 3 defects on an average. Correct? That's the reason I say for 10 meter square it is 1.5. So it can be 1.5. Here I wrote it as 1 because we started with the example as 1. But it's not necessary that it has to be an integer. Okay? The second point is the mean, which we represent by the letter mu or E of x, okay, is equal to lambda. The variance or sigma square, which we can write down in a short form as variance of x, is also lambda. So if you see, for Poisson distribution the mean is equal to the variance. Okay, that is why we say that there is only one parameter. Okay, then there is something called as standard deviation. So if the variance is lambda, then the standard deviation will be what? Standard deviation will be square root of variance, positive square root of variance. So the standard deviation is equal to sigma, not sigma, what is this called as? Yeah, sigma only. It is square root of lambda. Okay. Then probability of the random variable taking a value r, this can never be negative. It can never be negative. You very well know that probability can never be negative. So here also the probability of that random variable taking a value r can be negative, never. Then last thing, summation of all the probabilities. Okay, when I take probabilities of x taking all the possible values, like here I said r can take all the possible values 0, 1, 2, 3, 4 and so on up till infinity. So the probability summation of all the probabilities of the values which x can take, if I add up all those particular values, the probability will be always equal to, the sum of the probabilities will be always equal to 1. Okay, that's it for this particular video. In the next video we will take some examples on this particular topic.